Hi, in this video, I'm going to teach you a very nice shortcut way to factorize quadratic polynomials. In the board exams, they often ask you to solve quadratic equations by factorization. In the school, when they introduce this, usually they use nice simple numbers where the factorization is very easy. So you can just guess and figure out how to factorize. But in the exam, they'll give you numbers which are much more difficult, and so then factorizing becomes quite tedious or difficult. And what you're going to see is, using this technique that I'm going to introduce, you're going to find that it's going to be super easy to factorize any quadratic polynomial. My name is Balaji Sampath, and I have taught thousands of students and helped them top their board exams and also crack competitive exams like the IIT, JEE and NEET. And today we are going to learn a nice simple technique to factorize quadratic polynomials. Okay, let's get started. So let us start by looking at how do we learn factorizing of quadratic polynomials when we learn it in school. Okay, so for example, let's take this one, x squared plus 5x plus 6 equal to 0. And usually what do we say? We must take the middle term and we must split it, right? So we basically split it as mx plus nx. M plus n must be equal to b, which is 5. And m into n must be the product of this term and that one. So basically this coefficient and that one. So 1 into 6, which is 6. And can I come up with two numbers that add to 5? And when you multiply, you get 6. Very easy, right? M plus n has to be 5, m into n has to be 6, 2 and 3. Right? So it's very easy to figure out that the two numbers, just by guessing, you can figure out that the numbers must be 2 and 3. And then what do? You say, okay, let's write this as 2x and 3x. So when we split it up as 2x and 3x, then this is going to be x times x plus 2. And that's going to be 3 times x plus 2. So x plus 3 times x plus 2, because x plus 2 is common factor, you can pull it out and you can factorize. And if you factorize it like this, x plus 3 into x plus 2 equal to 0, this has to be 0 or that has to be 0. So x has to be minus 3 or x has to be equal to minus 2. So this is what you learn in school, right? So this is the factorizing method that we learn in school. Except in the exam, you won't get such simple numbers like 5x and 6 and so on, right? You will end up with something that looks like this. X squared plus 22x plus 117 equal to 0. So now 22x has to be split as mx and nx. So m plus n has to be 22 and m into n has to be 117. A into c, 117. Can you now figure out what two numbers will add up to 22 and when you multiply you get 117? Not so easy, right? This is definitely not at all easy. So guessing this is easy, and so when we usually introduce it with that, it looks like easy method. But when it actually comes down to numbers like this, it is not so easy. So how do we then solve? I'm now going to show you a different way of doing this, which is also factorizing, but we are going to learn how to do factorization by completing squares. Okay, what does that mean? Well, look at this, x squared plus 22x plus something, right? Now, x plus a whole square. X plus a whole square is x square plus 2 times a times x plus a square. Now, this relationship, you know, a plus b whole square, you know that same formula here. Now, do you have x square? Yes. And this one, can I write it as 2ax? 2 times something times x. X is already there. You can always put a 2. So 2 times 11 times x. Okay. So if I did that, then I will be able to rewrite this as a nice perfect square plus something extra. Okay. Let me show you how to do that. So what you do is you take the middle term here and write it as 2 times something times x. You can always do that. So x square plus 2 times 11 times x. It's 22x, I've just written it this way. It is different from what we are doing there, but you will see that we can factorize this way as well. But if I have 2 times 11 times x, the next one should be 11 square, right? Only then you can write x plus 11 whole square. So I'm going to put 11 square. But you can't just simply put 11 square, it's not there. So put a minus 11 square. But there's already 117, so add 117 equal to 0. Notice that I have just added and subtracted 11 square. The reason I did that is because this part, using this relationship, right? You know this identity. So it is x square plus 2 times 11x plus 11 square. This is x plus 11 whole square. This is x plus 11 whole square. So let me write x plus 11 whole square. What is 11 square? 121. So 117 minus 121, right? 121 minus 117, well, that is going to give me 4. So 117 minus 121 will be minus 4. So minus 4 equal to 0, right? This is going to give me minus 4. So minus 4 equal to 0. This is like a square and 4 is actually b square, 2 square, right? So we can write x plus 11 square minus 2 square equal to 0. Now a square minus b square, we know that formula. A square minus b square is a plus b into a minus b. So let me write a plus b. So x plus 11 plus 2 into x plus 11 minus 2. You can split that up, right? A square minus b square. And see, you're factorized. Because you see this is x plus 13, that is x plus 9. So x plus 13 into x plus 9 equal to 0. Well, that means x plus 13 must be 0 or x plus 9 must be 0. So x must be minus 13 or x must be equal to minus 9. So have we factorized it? Yes, we have taken this and we have factorized it by first writing this portion as a perfect square and then writing the remaining as just a number, and then of course writing that number also as a square, and then basically using a minus b into a plus b. So this is one nice way to factorize quadratic polynomials. Okay, so let us see how to use this by looking at a few examples. Let us now use this completing squares method to factorize this quadratic polynomial and solve the equation that is given. Okay, x square plus 46x minus 96 equal to 0. So our goal will be to take this 46x and write it as 2 times something times x. Well, 46 is 2 times 23. So we can write x square plus 2 times 23 times x. Okay, and before I write the minus 96, well, if you've got x square plus 2ax, what should I get next? A square. I should get a square. So here a is 23, so I should add 23 square. But that was not there in the question. Okay, so subtract it. Since we have added 23 square, I'm going to subtract 23 square. And of course, there was already a 96, right? Minus 96, and that whole thing has to be 0. Notice that nothing has changed. X square, this is 46x. These two will cancel out, minus 96. So I have not changed the question. Same question, just that I have written it this way. Why? Because this is of the form x square plus 2ax plus a square. So x plus a whole square. So this is x plus 23 whole square. And that is minus 23 square and minus 96. What is 23 into 23? 23 into 23, well, you can directly do it, or you can write 9, 6, and this is going to give me 6, that's going to give me 4. So 9, 2, 1, so 529, right? 529. So this is minus 529 minus 96 equal to 0, and these two together is 625. This is 625. 625. So 625 is 25 square. So you can write x plus 23 whole square minus 25 square equal to 0. So a square minus b square. A minus b into a plus b, or a plus b into a minus b, whichever way you want to write. So I'm going to write first a plus b. X plus 23, that is a, this itself is a, plus 25, a plus b, into a minus b equal to 0. And so what is this? 23 plus 25 is 48. So x plus 48 into x minus 2, right? 23 minus 25 is minus 2, so x minus 2 equal to 0. So now this product equal to 0. So we have factorized the given quadratic polynomial. So x square plus 46x minus 96. Let me write x square plus 46x minus 96 is equal to x plus 48 into x minus 2. That is equal to 0. Now, well, if this is equal to 0, this must be 0 or that must be 0. So x must be equal to minus 48 or x must be equal to 2. And so therefore the answer to this question is x is equal to minus 48 or x is equal to 2, right? So from there you will get x is equal to 2, and from this you will get x is equal to minus 48. So notice that by factorizing this, right, we are able to solve, and by completing the squares, right, we have completed this, we have made this into a nice perfect square. So that's why this method is called completing squares method. So by completing the squares, we can very easily factorize this given quadratic polynomial. No guesswork involved. So what do? We split the middle term as 2 times. We are not splitting into 2 different numbers. We are writing this as 2 times a times x. Okay, we write it as 2 times a times x, and then we put a square, whatever we get an a square. But because you added an a square, you have to subtract an a square, and then of course put in whatever else was there. And then we can go ahead step by step. Without any guesswork, we will be able to factorize and solve this question. Let us now use the completing squares method to solve this given question, x square minus 15x plus 55 equal to 0. Now, that middle term you have to write it as 2 times a times x, right? So does that mean that the middle term has to be even? Not required. I'm going to show you how you can use the completing squares method to solve this question as well. Of course, it's going to be a little bit harder when it is odd number rather than when it's an even number, but we can still do that. So let us see how to solve this. So first I'm going to write this as x square minus 2 times 15 by 2. So that way you see you get 15, right? X. But since I have written it like this, instead of a plus I have put a minus, it's okay. X minus a whole square is x square minus 2ax plus a square. So I must get a square. This is a, right? So I must put a 15 by 2 whole square. What is 15 by 2 whole square? Let me first write this down. 15 by 2 whole square. But since I put this in, I have to subtract 15 by 2 whole square. Well, what I will do is I will write the actual value itself. 15 square is 225. 2 square is 4. So I have added 225 by 4. I have subtracted 225 by 4. But there's already 55. That I must bring it back. Equal to 0. These two are equal. Effectively you are cancelling. And you see that nothing has changed. It is the same question that I have rewritten like this. What is the advantage? Now this is a perfect square. You can write this as x minus 15 by 2 whole square. Right? X square minus 2 times x times this. Right? You can see that plus 15 by 2 whole square. So exactly what I have written there. Right? So that is x minus 15 by 2 whole square. What about this one? 4 times 55. 4 times 50 is 200 and 4 times 5 is 20. So this is 220. That is minus 225. This is 220. So you're going to get minus of 225 minus 220 by 4. Well, that is going to be 5 by 4, right? So it's going to be 5 by 4. So I'm going to get this minus 5 by 4. This is going to be 5 by 4. But 5 by 4, if you want to write it as a square minus b square, then you should write it as root 5 by 2 whole square. Root 5 by 2 whole square. We can write it like that, no? It's not a perfect square, but so what? You can always write it as root 5 by 2 whole square. So let us now write what we have got. X minus 15 by 2 whole square minus root 5 by 2 whole square equal to 0. And so now we have got a square minus b square. So we can write a plus b, a minus b, or a minus b, a plus b. So let me do a minus b. So x minus 15 by 2 minus root 5 by 2. Into x minus 15 by 2 plus root 5 by 2 equal to 0. Have I factorized it? Yes. Right? This is one factor, this is another factor. So this equal to 0 will mean x is equal to, right? This is going to give me x is equal to 15 by 2 plus root 5 by 2. It will go to that side, right? So 15 by 2 plus root 5 by 2. So since it's the same by 2, you can bring it together. And if I take this to that side, right, this equal to 0, it will become minus 15 by 2 will go there and it will become 15 by 2 minus root 5 by 2. So x is equal to, right, from there you will get 15 by 2 minus root 5 by 2. So therefore these will be the answers. So x is equal to 15 plus root 5 by 2 or 15 minus root 5 by 2. By factorizing this given quadratic polynomial, we have been able to solve this quadratic equation. So I hope you have understood how to do this. Of course, little bit more cumbersome because the numbers are not so nice, right? So you have to do 15 by 2 and so on. But you can see that you can always use this approach. Okay, but this approach works very well when you have coefficient of x square as 1. If you don't have coefficient of x square as 1, let's say you have 2 or 3 or something, then you'll have to take that out, you have to bring that down and so on, makes things a little bit more complicated. And that's why I'm also going to introduce another way which is going to work for all different situations. So a nice shortcut way for you to factorize, but using that mx plus nx, m into n, m plus n. I'm going to show you how you can do that in the next video. So we have now learned the completing squares shortcut for factorizing quadratic polynomials. So for example, if a quadratic equation like that is given, you basically write the 22x as 2 times 11 times x. So then you can use the x plus a whole square formula to rewrite this as x plus 11 whole square minus 2 square equal to 0. So once you have written it this way, then of course you can say a square minus b square is a plus b into a minus b, and then using that we can very easily factorize this quadratic polynomial. Okay, so we've seen how to do this, and you will see that this removes the guesswork that is required in finding out m and n. But here, without any guesswork, we can step by step arrive at the factorization. Except that if the coefficient of x was not 1, it gets a little tricky because this method works really well if the coefficient of x square is 1. Otherwise also you can do it, but it gets a little more messy. And that's why in the next video I'm going to introduce an even better shortcut that works in every situation. Okay, so we're going to learn that in the next video. So I hope you understood and learned this concept of completing squares to make factorizing quadratic polynomials very, very simple. If you like this video, please subscribe to the AHA Guru YouTube channel so that you can learn lots of tips and techniques like this that will help you with your exams.